Hello, this is our TSC assignment about subtraction of two numbers by Turing machine. This has been made by Janvija and Shashank Chandar. First, we'll introduce what's a Turing machine. A Turing machine is a hypothetical device that manipulates the symbols on a strip of tape according to the table of rules. That is, we have a tape, and now according to the rules, we can manipulate the symbols on that given tape. The Turing machine was invented in 1936 by Alan Turing, who called it as an A machine or the automatic machine. The Turing machine is not as a practical computing technology, however, it can emulate a computing machine as a hypothetical device. This picture shows the original Turing machine and Alan Turing in it, which shows a certain sort of stacked tape, or we can call rows, and on which the symbols are embedded. Now we will give the formal definition of the Turing machine. The Hopcroft and Ullman in 1979 formally defined one-tape Turing machine as a 7-tuple, where M is the Turing machine, gives Q, and then it's gamma, blank symbols, sigma, delta, Q naught, and F. In the above formal definition, Q is a finite, non-empty set of states. Gamma is a finite non-empty set of the tape, alphabet and symbols. B is a blank symbol. Sigma is a set of input symbols. Q naught is the initial state. F is a set of final or accepting states. And delta, we call it as a transition function, where we can, which helps to tell us how we can move on an input tape. This is the basic original idea by a Turing machine. We are given a set of tape on which there is the rollers, which tends to move the tape and put the input symbols on the tape. We have a memory dial, and there is a scanner which tends to erase or write the symbols, and we have a logical control in order to understand the arithmetic logic behind the Turing machine. Now we will show the model. The typical mental model for Turing machine has been shown in the given figure. In this, we have a tape, and then we have the symbols embedded on the tape. We have a reading and writing head which can move in either left or right directions, and the reading and writing head is being controlled by the finite control. A Turing machine terminates abnormally whenever a computation tries to move left of the leftmost tape square. Now we will explain a bit more about model. In this, the Turing machine has a tape that is unbounded in both the directions. As I said, it can move already left or right. However, the Turing machine is said to be deterministic in the sense that it only defines one move for every configuration that it intakes. There is no special input file. Similarly, there is no special output device. Now we will go with the problem.
Now basically a problem. The problem is to perform subtraction of two numbers via Turing machine. That is, for example, we take x and y. Now moving on to the next slide. The basic idea what the algorithm that we are using is, basically we are representing all the numbers. Suppose 5 is represented by 5 zeros and minus sign is represented by 1. First of all, we go to the rightmost zero and convert it to a hash, and for the same at the same time we come to the leftmost zero and make it a hash. We continue this algorithm till we encounter a 1 when moving left from the rightmost hash. Then we change 1 to hash, and the resulting zeros are the answer. Now as we see this Turing machine, we move on to the Q naught state. We move on to the right side till the time we encounter a 0. As we encounter a 0, we replace it with a 0 and move right. We move on to state Q1, which is an intermediary state. Over there we apply a self loop of 0 and 1 and move on to right, replacing them with themselves respectively. When we encounter a hash, we replace it with a hash, move left. We move on to Q2. At Q2, if we encounter a 0, we replace it with a hash and move left. We move on to Q3. Q3, we again apply a self loop of 0 and 1, replacing them with themselves and move left. As we encounter a hash, we replace it by a hash, move right. Then moving on to Q4. From Q4, when we encounter a 0, that we'll always do, we'll replace it with a hash and move right. Now the process continues till all the zeros have been converted to hash, which are what we say right to the ones. When we go over there, we move on to state Q2, and then we encounter 1, which is replaced by hash and then moved right or left, which doesn't matter, and we move on to the final state. Now Q naught is a start state, QF is a final state, Q1, Q2, Q3, Q4 all are intermediate states. Now this is the transition table. From state Q naught, we move to 0 RQ1, then 1 is nowhere in the picture. Then second for the hash function, we use a hash RQ1 again as we are moving right. Then for Q1 we go as 0 RQ1, then For one, it's one hash qf, like as we showed in the machine. Then for hash it is q, this is hash lq1. Similarly it goes for all the states, and in the end we reach qf. Now this is represented, we are representing the transition states. We are showing the current state and the new state, which are changing respectively as along the different states, as we can see. That will be all. Thanks a lot. Thank you.
That will be all, and thank you
Thank
from
you.
both of us.